Oh, no.
Yeah, I think I started on my end.
Yeah, it started as well. Let's see. Okay. Looks like everybody's here from all the groups. Are we missing? Is anybody missing a team member?
Not here.
All right. So I guess we can start. We can do it by if anybody wants to go first, or we'll just do it in however it's ordered on the spreadsheets. Anybody have a preference of going first? All right, let's just start with minimize remote devices and cloud computing.
It's good. I think it's our group.
What was that?
So that's our group. We can go ahead and start.
Okay, so Ivan's group. How are we supposed to share?
No, it's not Ivan.
It says the breakout rooms are about to close.
Yeah.
Oh, are they?
See.
That was weird.
Let's ignore that, I guess. I guess once everybody gets back in, at least.
Okay. Can you guys share screen, or is it only a me thing?
I have an option to.
Like all the other presenters?
Michael said his group is going first.
Okay.
Yeah, we're minimized remote devices.
Okay. You guys can start it off then. Everything
Okay,
should be recording.
We're waiting for one more group member to get back in.
Okay,
what?
that's fine. Can you guys, are you allowed to share your screen? Like, do you guys have access? Okay, it looks like it's working.
Yeah, you can see it.
Yeah.
Yep.
All right, you guys can start whenever you're ready.
Still waiting on the other group member. I don't know where he went. Or I know he got kicked out.
Let me see.
He said he was having computer issues, so I don't know if it's that.
Okay.
Just message him real quick.
Yeah, we gotta wait on him then.
Okay, there he is.
All right, perfect. You guys can start whenever you want.
Yeah, all right. So we wanted to look at computers and gaming consoles with our project and just kind of see how we can minimize what kind of hardware we have. And yeah, what can we do with cloud computing that's not being implemented well right now or at all. We can look at technology we have now, like smart TVs and Apple Watches, and discuss where these technologies can lead us, as well as like things that are holding them back, and how we could implement them better. Yeah, when we talk about shifting from a local system to a server-based system, we're talking about and aiming to reduce the hardware we have at home, like our consoles or our computers. So our ideal setup or the idea is to just kind of just be having an input device like our controller or kind of keyboard, mouse, and a display that's able to be connected to the internet with a reliable connection. And yeah, and that's all we have, as opposed to having a console and having to take care of our own server or whatever, just trying to minimize what we have to do locally. If we can kind of shift into streaming computer calculations and not needing to allocate the local hardware, then this makes our devices more portable and just, more portable. And what we need for that is, bigger speeds and we've kind of already seen this transition in action with video streaming services in the film industry, because VCRs and DVD players, you don't have those everywhere anymore. They're no better than streaming apps, and you just need an internet connection and an input device. And that's kind of what we're talking about on a bigger scale, maybe like with computers and with gaming, even just having the input device, your display with a connection, and no other hardware. Without diving into more complicated issues like security, we wanted to talk about issues with this idea, like internet traffic, internet traffic, the infrastructure that would be needed to implement this on a large scale, and data transfer speeds. Traffic is going to increase a lot if we are able to implement this in not just with video streams, but like when you're using everything, with everything your computer can do is streamed. So like things that maybe you wouldn't need Wi-Fi before to do on your computer, you're now needing an internet connection to do that, because you don't have the hardware locally, and that creates a lot more traffic. So we need to be able to support that traffic and have faster speeds. If you want to do more calculations, you don't want to, if you're just typing to your screen, you don't want latency with that. You're also going to need a much bigger infrastructure when it comes to internet, because even now you can drop phone service or stuff. And if we want to make this more portable, where all we need is a screen, and we don't have our own server, then this isn't just at home, right? You'll need to, you would like to be able to take your device and your input and just kind of go anywhere. You could go to the park and play some COD or whatever. It's just, but to do that, you need to be able to have a good strong connection in the park, and that's kind of what we're talking about. Data transfer speeds also need to improve, because the amount of data being transferred is going to be larger. I think I already touched on that. Just when you're having real-time input and you have a lot of traffic, you've got, yeah, even if you have that big infrastructure and you're able to transfer it and the system's able to handle it, it needs to be fast enough for it to be practical and to look seamless. And yeah, I think for when it comes to more inputs, we kind of, yeah, you gotta start thinking about latency and stuff like that. So.
Yeah, so thanks, Pierre. So I'm going to continue this conversation of cloud computing and focus on latency and specifically gaming. So gaming via cloud is innovative and it's an appealing idea. If it's implemented properly, as Pierre was saying, it becomes frictionless and allows for this minimized setup. Cloud gaming exists. Microsoft released Xbox Cloud Gaming, and it's currently in a beta. I would encourage everybody in here to go and try it, and then determine for yourselves, like, is it a pleasant experience as is? What you'll probably find in its current state is that it's not pleasant at all. There's a significant latency issue. However, if latency wasn't an issue, would you use it? Would you subscribe to the service? Is it sufficient for your standards? I mean, all you need is a browser, a controller, and a reliable internet connection, like Pierre said. And it sounds pretty great in theory. The most frustrating part with online gaming right now is lag. And this is going to be easily noticed with Microsoft's cloud gaming. Most people that played online multiplayer games have experienced some type of lag or latency. And if it's significant enough, it's very frustrating. I mean, my personal experiences, I've been in situations in which lag has prevented me from maybe getting a kill on another opponent in that game, or it led to them defeating me. And if that type of latency continues on, it becomes just unpleasant, and I just don't want to play the game anymore. So the three types of latency I want to touch on are client, network, and server. Client latency is sending your input and then receiving everyone else's actions on the same server. Network latency is going to be the communication between all the clients and the server. And then the server latency is sending and receiving all actions to and from everyone else that's on the server. With cloud computing, a large portion of the client latency is actually going to be transferred to the server. That's the whole idea. Now, especially when you have multiple users utilizing cloud computing for gaming, that server is going to need to be drastically improved. You're doing all of the typically what would be local hardware computations for the game and making the server do all of that now. With that, more data is sent and received, as Pierre said, and we're going to be dealing with a lot higher network traffic. So overall, server latency and network latency dramatically increases with cloud computing. What we're trying to figure out is this an issue that can be overcome? From all of this, though, what we can gather is that cloud gaming is essentially the benchmark for cloud computing. Is there any other industry that requires high-speed, latency-sensitive transactions more than the gaming industry? If cloud computing is conquered, then virtually any other cloud computing implementation can be designed. I'll now ask Kennedy to continue on with this conversation. Thank you.
Yeah, so our third topic that we wanted to kind of discuss and look over and geared our focus towards is the possibility of furthering virtual mobility. So how like everything we want to take seamless and kind of taking rid of that mechanical part of it. We wanted, and if other applications took like the same implementation, such as the gaming and minimizing the remote devices. So one of the resources that I found called The Future Impact of ICT on Environmental Sustainability explores the technical side of how like businesses and websites and machines would perform based on virtualization, rather than the physical input output system where you're like plugging in HDMI to like a console. The main topics discussed from that we would explore along the lines of how like gaming systems work seamlessly. And these would include the ability to like pre-allocate memory and use virtual power stations and things like that. Some of the examples in the studies that were given were experiments of how society would function with a virtual mail only system. So kind of like when you're emailing or like you get things shipped and they're exploring like how you would eliminate the console, such as the mailman. So everything would kind of just be virtual in that side. But these aspects can be applied to telework for businesses and other main examples. And the source was building into reality, like kind of like the smart fridge, where in the study kind of went over if they take it to the next level, how now you have fridges where you can see what's inside, and they're saying in the future, basically that screen would be able to set up a subscription where you are able to have it order things for you, and you pretty much eliminate driving, going to the store, and searching on websites. So kind of along the lines of that is what future applications we were seeing. And then going into the significance for our review is that we are focusing on the idea of minimized devices. So the convenience factor of eliminating the physical, like mechanical equipment, and having the cordless environment is an increasing appeal. And with gaming, the idea of cloud computing and not saving to the hardware piece. And we also just want to focus on how this applies to future devices, and the same idea with cloud computing. And so for our schedule, this is kind of what we lined out based on when we're presenting, and then our focus areas on what we want to focus on for the literature review. And to conclude, the goal for us for this literature review is to observe how the minimization of hardware drives can create like a more user-friendly environment. And throughout our project, we want to kind of evaluate and transition to cloud computing and see how this relates to gaming and how we can kind of gear that focus towards future innovations. And then our references are there. So yeah.
I believe this would be the start of the Q&A.
Yeah. So, do we have any questions to ask them about? Anything to clear up?
I mean, I've got a question about the latency from Xbox, their cloud gaming.
Yeah, go ahead.
Did you say you tried it?
Yeah, so and I'll hopefully be including that in my presentation. So it'd be cool to give a demonstration of that. But what's your question?
I was just gonna ask, like, how bad was it?
It's not playable. Can't play anything competitive, but it's close to playable. Like you can definitely see they're onto something. And
Yeah.
as we kind of mentioned in the proposal, is that if that latency wasn't there, like if I have a controller and a screen or maybe like a phone, and I know you can use I think you can use their application on an Android phone as of now. So like if I have my Android phone at the airport and my controller, and I'm just hanging around, like can I play some games to kill some time? It's a very interesting idea. But to answer your question, at its current state, it's not like you can't play any competitive games or anything like that. Anything that's higher paced, you might be able to play like a real-time strategy or something like that, where it's just kind of turn-based.
All right.
Do you have any other questions?
I have a question. Great presentation, guys. But I was just thinking. So, you see cloud computing gaming?
I'm sorry, it's hard to hear you.
Yeah, I know. There's like they're cutting down trees right now, so I'm gonna try to talk about it. Do you think that cloud computing gaming is going to be? Do you see it being more playable? As you said, right now in its current state, it's like not too great, but within like the next year or two, or you think it'll take even longer than that?
I'd say, considering the infrastructure limitations right now, it's probably going to be, I'd say it's more along the lines of like 5 years. We definitely need higher data transfer, because the whole point with cloud gaming, we're asking the servers to really do all like the hardware computation. So that's like graphics rendering and stuff. And then that data has to be sent back to all the clients, as well as all the other functions that it already performs. And we already deal with lag with current gaming now. It's not 100%, right? I mean, most of the time it's pretty good, but just sometimes we still deal with lag now. So in my opinion, I'd say at least 5 years down the line, there's got to be some infrastructure innovation with that. I think fiber and 5G will assist with that a lot as we start to tend towards that infrastructure.
I definitely agree with him with like the 5 years, because when you see what Xbox did like with their new like virtual kind of thing where you didn't need the console, it took them a couple years to kind of figure that out and bring it out. So I feel it definitely would take longer than 2 years to kind of upgrade it and get rid of that lag.
Yeah, if I could chime in on it too. Yeah, I think that we have, like, it exists, right? Like you have a cloud streaming game, you have it with Xbox already. You just kind of we just kind of want to see how far we can take it and how, like, yeah, you have this kind of technology already. It's just how far can we go? What's holding it back right now? And I think we kind of want to explore that, and just see what is holding it back. And is it just we can fix the infrastructure, or if there's a way to transfer data faster, will that fix it? And I think if we figure out the competitive gaming, like that's the most demanding, application of this, really. So it's like, if you can figure that out, if we can figure that out, or solve, or yeah, just figure out what's holding it back, and that's what would be holding everything under cloud computing back. So it's like, if we can solve that issue with competitive gaming in particular, then any other issues, any other latency issues, any other, kind of things of that nature kind of will be a lot easier to figure out, because it will be it will have less requirement than the competitive gaming.
For sure. We got any other questions?
Yes. Do you believe it's for the majority a issue of latency network connections, or can there be more of a optimization in the server space? Because I know that rollback netcodes have been very helpful in, say, a fighting game, but haven't had much success or any application in any other genre. Do you believe that implementation of something like that kind of algorithm in overall cloud computing could be helpful for any other kind of game that you're thinking of applying this to?
So I think right now, one of the bigger limitations with servers and whatnot is that they're just not used to like rendering high quality graphics, right? So that type of data transfer is pretty primitive on the network right now. I think compression algorithms would help with that, as well as again, I think the network speeds are going to have to be faster, because we're talking about like a good latency in a game. Just it's typically somewhere around like 80 milliseconds or less, right? So now you have to have your server process all that, which takes time, send that data back to you after it's received your input signals. And meanwhile, it's receiving all of these input signals from all the clients on that server. And a game typically consists of 8 to 10 players, if not more, such as like Halo or Call of Duty, or more popular ones in that regard. But I think you mentioned a fighting game where it was like kind of like a 1v1 type of situation. Yeah, so on that, I think I haven't tried that out, and I'm interested to try it now that you mentioned it. I don't know how well that would perform, because typically it has like a pretty consistent background, not much environment, and it seems like it'd be a lot more feasible than a action-packed game where you're constantly running around, sliding around in a totally different environment and rendering graphics that whole time. I'll try that out for sure.
Sounds good.
Cool. I think we're getting to our 5 minutes here, so
Yeah,
go
we
ahead.
start moving on to the next group.
For sure. Thank you guys. I really appreciate it.
Thank you. All right, next up we have Google Stadia latency tolerance.
Yeah, that's my group.
All right.
Oh, thanks, Elmo. I had it pulled up, but that's all good.
Okay, you have it.
Nah, that's okay. You can go ahead, man.
Okay.
I'm pretty sure it's Alt F5 to.
Right. So hi everyone. Al-Mu'tasim. Today my group members are going to present about cloud gaming. So here we have Anthony and Ivan.
Elmo, I can't see it.
Oh, you can see it?
Is that just a me thing?
Nah,
No, I can't see it either.
We see your screen. We don't see the thing. There you go.
There
Do
you
you
go.
see it now?
Very good.
All right. So hi everyone. My name is Al-Mu'tasim. Today me and my group members are going to present about cloud gaming. Okay. So first, let's get before we get to know what's cloud gaming, let's get into the definition of the cloud gaming. So cloud gaming is it's a method that is used to play video games in remote servers. So the user does not need to buy like a very strong computer to play video games. So anyone can play video games without needing to buy or to spend much money on a very strong computer. And to know how cloud gaming work. So cloud gaming is basically the same thing as you have a game in your computer. The difference is just that the game is in a remote server. To explain it more, let's take Netflix as an example. So Netflix have a lot of movies, and the user can watch the movies without needing to download these movies. So it's the same thing for cloud gaming. But the servers that used for cloud gaming can pick up and interact with the user's input. So this is the difference between the Netflix servers and cloud gaming servers. And there are different runners for cloud gaming, such as Google Stadia, the one that we choose to talk about. And like there is another ones, for example, GeForce Now and Xbox cloud gaming. So as many other things, these cloud gamings has like problems. One of this problem is that they need a very high speed and good internet connection. Without that, cloud gaming servers will have like problems on running. And many different places in this world, they don't have like a very good internet connection, which causes a very good problem. The second problem, they call it data capsules. This problem affects more the cloud gaming servers more than the user. So for this problem, the user have a very good internet connection, but the user requires a much higher data than the server can provide, which will cause on destroying or damage the server. The third problem is video compression. It's just like the videos on YouTube, they are compressed to use less bandwidth. It's the same thing for video games and cloud gaming. They are compressed, which will not make them as sharp and detailed as as what a very good and strong computer can offer. And the second problem, which is the big problem, is the latency. So to explain this problem more, let's say you are playing a game and you are moving your mouse. So the motion of the mouse and the computer will be transferred through the internet to the remote server. And there is a reaction that's going to happen in the remote server. And this reaction will be need to send back again through the internet to the user's computer. And this process takes a very long time, which causes the latency. And it's the main problem, and that we are trying to focus more on.
Hello, everybody. My name is Tony, and I'm going to talk about a little bit of the importance of cloud gaming and why we sort of chose this topic. First of all, as mentioned before, it's a pretty tough act to follow as well, the last group, but the elimination of expensive hardware like gaming consoles, PCs, and other related components like GPUs, CPUs, and other graphic cards like that. It'll also cloud gaming will also help sort of eliminate the exclusivity of certain game libraries like I think Halo is obviously exclusive to Xbox. I think the new Spider-Man games are exclusive to PlayStation. So anybody, anywhere should be able to, play any game on pretty much any device that can connect to the internet. Cloud gaming will also influence, other industries and other technology advancements. Is sort of like it's just like a competitive nature thing. We think that it'll sort of influence people or companies to push for improving already existing technologies like the cellular industry, improving 5G networking, and advancing and just advancing all specs pretty much across the board. Internet speed, reliability, data storage capacity, things like that. Alma, you can go to the next slide. Okay, so yeah, this is our schedule. This is kind of just what we planned out. Unfortunately, the formatting kind of messed up there. But this may change as well as sort of flexible. Almo is going to sort of take care of the data storage and data center infrastructure. Ivan is going to focus on latency and real-time processing and all relating things. And I'll sort of handle bandwidth and traffic control, how the traffic is handled, how high frequency inputs are handled, the cost of all of this, I'm sure the cost of data storage will be discussed. The cost of really improving all of this, across the board, because there, as it was said before, that cloud gaming in its current state is not great. So it can definitely be worked on, and also just how these things are handled by companies or services like Google Stadia, and how they handle these things right now, and how bad it actually is, data transferring speeds and video quality and things like this. Oh man, once again the formatting kind of got messed up. This is our objectives. Our general objective here is to just demonstrate what cloud gaming is, and how the user interfaces with it, and how it can be improved, what technology can sort of assist in that and reaching that optimal stage, and where it can kind of compete with local servers and gaming on local servers. And also just show the relationship between technology and the state of technology in general, and how that is kind of facilitating the growth in cloud-based processing and cloud gaming. And then also, just like I mentioned before, the complications and the burdens that cloud gaming faces now, and what it's going to take to sort of overcome those and see it where we want it to be. Thank you. Oh, there it is. Cool.
All right, my name's Ivan, and the preliminary research for this, we found that we could use edge nodes at partner internet service providers to provide fast data processing. It would be easier to send data to a closer server than it would be to send it to a server. Like, the closest server to us right now is in North Carolina. And it would be much easier to send it to a server in Daytona Beach. And you'd have less latency with that. But the issue with that would be the cost. It would be more costly to use someone else's servers in order to do your own data processing. But there would be no upfront cost in that, because it wouldn't be you buying those gaming components, those GPUs, those CPUs. And with video compression, with Google Stadia, Google already owns YouTube, so they're really great at video compression already. They know how to seamlessly switch between quality and compression and give you at least a pleasant viewing experience, if not the best quality. So Google's already pretty good at that, and they shouldn't have a problem implementing that with Google Stadia. With the adaptive bitrate, this would reduce the number of errors in sending the packets to the servers, because if a certain link can only handle so much bandwidth, then if you reduce the bitrate, you would have less dropped packets, and so you would have greater reliability in that connection, and you wouldn't need a stronger connection. But if, say, you have a really good connection suddenly, then it would be able to automatically increase the bitrate, so you'd have a better experience and more quality. You can go to the next one, Almo. In conclusion, Google Stadia must implement features and protections for a successful product. Like I said, if they don't have good compression, if they don't have quick responses, then people are going to be less likely to play it. If I played a non-multiplayer game on Google Stadia, I would not find it enjoyable if it had latency, when I could just play it on my own computer at home. But then again, if you're playing online games and you don't want to spend money for a high quality setup, then yes, maybe this would be a good option for you. Connection speed matters. Like I said, if your connection isn't good, there's really not much you can do. You're probably not going to enjoy the experience. And that's why it says the recommended minimum is 10 megabytes for 720p and only stereo sound quality. But obviously, if you have a fiber optic connection to your house, then you could probably get a much better stream. Quality and profit is also important, because if they don't make enough profit, they can't sustain having these servers and buying more and having more computing power and keeping up with the heating costs of running all these games. Because previously it would be at the user's house, and now it's at the server rooms. And this would just be a lot more data for them to process. So they would definitely have to go through a lot more heat and energy, and they would have to have good margins, is what I'm saying. Hello? And here are our references. Any questions?
Yeah, I got a question. So what like improvements do you think would be needed to like implement like different changes? Would you say, hardware or software would be more important? Like, which of the two would be
I would
focused on?
say they're both pretty important.
Yeah.
Like, hardware would be more important because Google already has pretty good software with its video compression, but hardware is still lacking in many places. Like, I don't think my place right now has fiber optics, so it wouldn't have the best quality.
Right. Okay, thank you.
Right. Just to add to that, I think that there's definitely room for improvement on both sides of that, hardware and software. I know that there's already existing software where servers will kind of like allocate the nearest server to wherever the end user is, and it'll send whatever content that the end user is trying to retrieve to the closest server to them, and get it to them that way to try to speed things up. And there's also another server or another software that helps handle the traffic control, which I can't really remember what it's called, but I'm sure there's got to be improvements that can be made there, and yeah.
Tony, I had a question for you. I think you said something about so games wouldn't be exclusive. Were you speaking from like a hardware perspective, or can you elaborate a little bit more on that?
Yeah, just requiring the device, like in the sense that I can't take a PlayStation game and play it on an Xbox.
Okay. So there'd still be like exclusive applications though, right? Like you still have to get an Xbox app or a PlayStation app on your TV, if you will, right?
Sure. Yeah. Sure.
Okay.
Yeah. Sure. Thank you, by the way.
Appreciate it.
All right. There's no other
I'll ask
question.
another question.
Oh,
What do you think
all right.
the biggest challenge is with Stadia right now?
I would say it's the hardware.
Hardware?
Like, because Google servers currently aren't equipped to handle video game processing. They're more able to handle data processing, not particularly math, which would be used in video games.
Mm-hmm. Makes sense.
All right. Any other questions? If not, can move on to the next presentation with mobile cloud computing.
Is that group here?
Yeah, we should be here. Somebody wants to
That's us, right?
pull up the
Okay.
presentation.
Cool.
I can share my screen.
All right, so this is our presentation. My name is Thomas Wynn, and we're going to be talking about the impacts of mobile cloud computing and social media. Next slide. So what exactly is cloud computing? I'm sure, this group has researched a good amount of cloud computing, essentially just using another person's like computer or server instead of like using it on your own physical device. And there's many different types of cloud computing, like public, private, hybrid, etc. And you have a whole bunch of different services. We won't be going into that. We'll be more focused on, the actual social media aspect related to cloud computing. And, mobile cloud computing is pretty much the exact same as cloud computing, but instead of being, on a stationary device such as a, computer, you'd be more on like a laptop or a phone. So that is essentially cloud computing. So how does this exactly relate to social media exactly? Well, a majority of people have some sort of social media app on their mobile device, whether it be YouTube, Instagram, etc., whatever you're into. And social media has a large amount of images and videos that can be run. So we should be able to look at these images quickly without draining our battery life and not have everything downloaded to our local storage, hence why mobile cloud computing is used to mitigate this factor. So now we can go deeper into the problems of mobile cloud computing.
Yes. So there's about 3 categories of problems. There's more that we will touch on in our final presentation, but for the purposes of the proposal, we're just going to present them as 3 to better divide it up. One of the hardest issues with these problems are, since there's so many mobile devices and since there's so many people with access to a mobile device, any small issue is exacerbated. Any small ripple is felt by a lot of people. As you can see by this little diagram that we have, which is derived from some UN census data, there's over 5 billion people with access, or there's over 5 billion mobile devices, which means a lot of people have access to some kind of social media app. They have some access to mobile cloud computing. And because of that, the first thing that we want to talk about is, say, the quality of communications. After all, there's only so much bandwidth in the air, surprisingly. Latency is always inevitable when doing any of these cloud computing projects. And since our service spaces are very much physical, there is a limit, or an upper limit, of what they can handle before these products that we're providing all these mobile devices start feeling not user-friendly, too slow, out of date. There's a whole bunch of ramifications there. Next issue, I suppose.
So yeah, and then we have the issue of lack of storage transparency. What's going to happen to those data losses? You know, social media companies always want to reduce their data loss as much as possible. People can be upset when they lose their photo that they posted online, like, I don't know, 10, 15 years ago. It'd be like, hey, where's the picture of my grandma? And it can also be a huge issue with the company itself, seeing how if they have their data lost, that's a huge amount of time and money wasted and drained. There's also the issue with data caching. With so many users logging on and off at the same time, it becomes a hard thing to handle all that information all at once. How do you handle so many users going in and out of your servers at the same time? How do you make it so that, you know, not so many users can overload the servers? Like, they have to find out the problems of that and be able to solve it. And it leads into like server space, because they can't exactly store every single thing efficiently. If you look at certain apps, such as like TikTok, where they have a mainly video-based format, and videos take up so much more space than like images, so they have to figure out something to do with that. And with all this data, it leads into our next issue of insecure data transmission.
Yeah, so mobile cloud computing, one of the problems with it is insecure data transmission, because it provides data transmission through an insecure channel with the help of the internet. And with how widespread and how large the internet is, it has a lot of vulnerability throughout. And that's also why we have like antiviruses, we have stuff to protect us against malware and other issues. But with all these different security threats like imminent, we have problems such as impersonation and masquerading. So this is where, as most people know, that you basically take someone's personal information, pretend to be them, and then you gain access to private accounts like bank accounts, credit cards, different passwords. And so it becomes this large risk that mobile cloud computing contributes. And I guess basically this problem is extending to all the users that have access to social media because of websites requiring personal information to be filled in. So all this gets saved into the cloud. And so all these photos, all this name, address, like phone number, all this is uploaded to the cloud. And so someone somewhere else can always access it as long as they know how to.
So why should we care about, social media and cloud computing? Well, mobile devices are becoming more and more widely available, as shown in the last slide, some odds of 5 billion active mobile devices. And so with every new improvement or downside of mobile cloud computing that's discovered, this will basically affect almost every single user that has a mobile device. And since security issues are becoming more relevant as time goes on, what happens is that the user might try to look at their social media page and be like, oh, I don't exactly want these images to everybody, so I'll just make it to my friends. But what happens if there's an error in that system and then these photos become available to everybody anyways, even though you're trying to keep your own privacy to, a close round of people. And then we also have the issue of packet loss, which is a consistent issue because people want to see their videos at a consistent rate. They don't want buffers every 5 seconds when they're looking at YouTube. They don't want, these annoying connection issues. So being able to optimize the data and get these information to the user quickly will have a better quality of life.
So our objectives are simply to better educate ourselves on one of the most widely available cloud computing networks. And we have the focus of social media, one part out of curiosity and the other part to help us narrow down our focus of study. After all, I'm sure across all of our research into this thing, there's a lot of different angles to tackle it, and there's a lot of things to read. And I can tell from a lot of experience that some of these scholarly articles, although they are very reputable, they're very knowledgeable, and is a great source of information, they are not really digestible. So next slide. So I have read quite a bit of articles, and we've compiled a few if anyone would like to read about just the general things, or more general things that I've seen that are actually pretty well sourced. So we have a few sources just detailing the current state of general mobile cloud computing and the several issues that they face, how they deal with several kinds of latency, and how they handle all their users. And I also have found two similar-ish articles detailing a thing that they like to change, either for cloud radio access networks, is how they want to handle different, how they want to broadcast different kinds of signals, and they believe that this will account for less latency at the end of the line, although there's going to be a cost to set it up. And the other one is alternating direction methods of multipliers, which I don't know why they do something complicated like that. I read it. It's just a different processing algorithm for user data caching, right? We plan to add on these as we go on, but these are what we've kind of based a lot of our beginning knowledge on. So next slide.
So moving on to the administrative content, we have our schedule for these upcoming weeks laid out. So the week one of, I think it's next week, starting July 4th. We just plan on gathering more resources and preparing or I guess this week, this upcoming week was, wait, what's, sorry, I'm a little scatterbrained, but this upcoming week we'll be getting more research material to prepare for the first draft. That's coming in week 2. And so if we look to our right, we have the work distribution. So we have Nick dealing with quality of communications. We have Thomas dealing with the lack of storage transparency. And then we have Chonside dealing with the insecure data transmission. So the first draft is pretty important because all the research material we've laid out so far is coming to fruition. Everything's coming together and we're seeing how everything flows together. And it kind of lays the foundation for the future. So week 3, we continue with more research material and possible second draft to kind of clean things up and maybe make edits here and there depending on what we need. And then week 4 comes, that's the finalization of our research paper. So we will finish up the paper and then start preparing for the final presentation, which leads into the final week, presentation week. And that's where we'll basically finish up anything we have left over for the presentation and then submit our final documents. So our final remarks is that our message is to spread awareness on how social media is impacted by mobile cloud computing, right? And basically why this affects people as users who actively participate in their daily life so that they are no longer blindsided to the potential concerns. So I know so far we've only laid out like the potential problems and issues that can arise with mobile cloud computing. But as we do more and more research, we'll see what these providers are doing to combat those potential problems. And yep, that concludes our presentation.
All right. Any questions?
Yeah, I have one. So you said, like you said, you're talking mostly about like the concerns of it. Like what kind of advantages would come from using cloud computing for social media?
It's more of like a safety precaution for things to not have a user's like private data be so leaked to like everybody. You know, if somebody wants to make it more private, they can. If they want it more available to other people, they can. And improving in general, like mobile cloud computing on like your phone or whatever could potentially like save more battery life in the future. You can have more available, I don't know, processing power to multitask, browse social media and watch YouTube at the same time on your phone if you really wanted. So it's just opening up more possibilities in the future so we can make better use of like our physical devices rather than just having it consumed by, you know, using mobile cloud computing.
So you see a future more where our devices are just able to stream instead of actually do something.
Well, it should be able to do both.
But lesser of
Streaming was just an example that I brought up.
Yeah, to add to that, I just think with cloud computing and especially mobile cloud computing, it adds a lot of flexibility, especially to you know, everyone's on the go, everyone's bringing the mobile devices everywhere. Not everyone can just bring their PC unless they have like a laptop. So it's creating different possibilities for the future and just advancing technology as a whole.
And one quick point I'd like to add, I'm sure we're all aware of how gaming laptops have kind of developed over the years and how loud and how much heat they can generate if they're like really meant to push the limits of what they want to do. So instead of the equivalent of that being a very large phone has a very powerful processing core, can do all these amazing things, we're kind of cheaping out, making the servers do a lot of that work. So that way your phone is just more convenient for you and still has a lot of applications.
But then what if you don't have a very good internet connection? Wouldn't you have a lackluster phone?
I'm sure that there was some things I found interesting that while researching that we've already been using our phones to do a good share of cloud computing already.
Yeah.
The bare minimum has been enabled around 3G. So moving towards 5G, we can notice the upward trend of you're going to have more and more things your phone's able to do on the cloud just through Wi-Fi, and hope for the best from there. It's going to be a little bit slower than a computer with a wired Ethernet connection running a game, naturally, but we are not asking as much of our mobile devices, and we can get a lot more out of it because it is a much more readily available platform or device. I hope that answers that question.
Any other questions? If not, we can move on to our last presentation, which is effects of cloud computing on gaming.
All right. Let me get some verbal recognition if you can see me here in a second with the screen share.
Yep.
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 Sweet, thank you. All right. All right, so our presentation is about cloud computing and how it could change the gaming experience. My name is Jonathan. I'm here with Corey and Christopher, and let's just get right along. So, high-level overview. What is cloud computing? I'm sure everyone in this chat has a very good idea of what cloud computing is, but high level, it's basically using someone else's computer in the cloud with your device that could be lesser, right? So you're using things like their GPU or the RAM instead of your own to maximize. Basically, cloud gaming is cloud computing with gaming. Just take a word out. So you're using servers, RAM, GPU, etc., to maximize the efficiency of your device through gaming. So why would we switch, right? Change is not the easiest thing for a lot of people. So this could be the question. And long story short, it allows less capable hardware to run high quality games, which is something that isn't feasible right now. So if we make this switch, then it could bring the access of high quality games to a lot of people who don't have the money or the access to it right now because of their hardware. Motivation. So GPUs, especially last year with COVID, were really hard to get. And if you got them, you're paying an arm and a leg for them. So imagine a universe where instead of perpetually buying a GPU that costs, $1,300, you could go and for those months where it's insanely hard and overpriced to get them, you could pay a subscription for whatever have you amount a month, $15, let's say. And you get all the capabilities that this $1,300 GPU would have given you. And that's just the GPU, right? What else? Low-end hardware. Let's say you got a 2012 MacBook Air. You're not running Minecraft on that, So you're gonna have to up the game in your hardware if you want to play games like Halo or Call of Duty or any of these really taxing modern, games. Energy bills. We're all college students. We have to pay bills. A desktop draws a lot more energy than, a tablet would. That's just plain and simple, Space, again, college students, not much space, especially if anyone had a shared dorm experience their freshman year and you're living with someone. Chances are there's not much space to go around and you're using every square inch to your advantage. So there's plenty of other opportunities where you might not just have the space to have, a whole crazy desk setup and your tower and monitors and among other things. And this is just a little funny one. Anyone remember back in elementary school, you would get that one free day where you could go on cool math games, but then you get to it and you can barely even run your speed run game. It's, lagging out every 2 seconds because you're running a, 1997 PC. All right, advantages. There's a lot of them. So your games are hosted on a server rather than personal hardware. That speaks for itself. Basically, it eliminates any need any need for high tier gaming hardware if you're willing to pay this term license to get access to the cloud gaming through, Xbox or whatever other subscription-based service that provides it. Another thing would be, as long as you have an internet connection, you could go wherever you want, or whenever you have a little bit of free time that you're trying to kill, you could just, open up your tablet, connect to this subscription service and just begin playing whatever, high quality games that you would play on a giant tower back home. And this might be one of our biggest advantages, is it could lead to a lot more secure gaming as far as cheating goes. Cheating is a huge issue, especially with a lot of new launches, because there's files and whatnot that you can download, and it can create a lot of chaos in video games. And piracy is obviously a given because you're paying for a subscription, so there wouldn't be any way to back end it if you were to be going through cloud computing. With that being said, I will hand it off to Christopher.
All right. Hey guys, my name's Chris. Talk about the current dilemmas and limitations we have right now. As of right now, it's currently going to require more bandwidth than if you were to just have your local device and not use cloud gaming. A big issue that we have right now with cloud gaming is latency, due to the fact that when you put in your input from your controller or mouse, wherever, it has to go into the server, right? It has to interpret your input, has to go through all this encoding, and then it has to decode onto your device again. So that's a big issue that we are looking into. Another big issue is the internet connection that is required. I feel like that speaks for itself. Another thing is that you will no longer have the actual hardware. I know some people like actually having like a disc, say you want to put it into your game. So subscriptions are taking place of actually having that physical, or even just owning it on your actual device. So you want to go into the next one. As of right now, it's in its early stages, but it's kind of been around for a while. There's this one company called OnLive that started up in like 2009-ish. Started up at kind of early, but in around 2015, Sony actually bought them out. So they took their all of their stuff that they've been working on. And now you see Sony starting to come up with their own, you know? So that's pretty interesting. Xbox is, as mentioned earlier, in their beta stage of cloud gaming. We're also looking at server locations, video codecs, and user interfaces to improve cloud gaming. I know right now some devices, older devices, aren't capable to run video codecs, which is pretty much the compression of the streaming. And that's something that we're looking into and are researching. So on this page, we actually decided to share 3 different companies that are working on this right now, and showing how their video bit rate is across different resolutions. I thought it was pretty interesting how these different companies are getting different results and what, and we're going to investigate how their technologies and codes and software is differentiating between each other. Another thing that we're looking into is how we're going to be able to run games with higher resolution, but also think about, you know, the latency that comes across, and that's also what we're going to look into.
Hey, guys.
Yeah, I'm going to hand it off to Corey now.
Hey, I'm Corey. I'm going to talk to you about our goal. So the overall goal for our project, we really just want to demonstrate and understand how cloud computing could revamp the gaming experience. So in order to do that, we want to focus on 3 main points. The first one being the network technology improvements that we're going to need to really allow cloud gaming to proliferate. So like as we mentioned, it takes a very high internet speed to really run the games efficiently, and not everyone has an internet like that. So we really would have to improve network technologies to really have cloud gaming be where we would want it to be. The second point is going to be the advantages and drawbacks of the security aspects. So like John was talking about, piracy and cheating. There's also the concern of just having your data always in the cloud and that kind of stuff. So we want to cover that. And then the last point is just how cloud gaming could completely replace the need for personal gaming hardware. So you'd no longer have to buy those expensive CPUs or GPUs. You can just stream it right to any device. Now we have our plan. So first 2 weeks we want to dedicate to researching. I think that is good. Have a lot of time to research and really look into everything. And then the 3rd week we want to write our first draft of our research paper. And then the next week we'll finalize the research paper and begin planning our presentation. And for week 5 we'll finalize the presentation. And then the final week we just have the 4 days before we actually have to present. We'll practice our presentation, go over it. And then we assigned each of us an area of focus. So Chris is going to focus on the network technology improvements needed. I'm going to focus more on the security aspects, and Jonathan wants to focus on how it's going to replace the need for personal gaming hardware. And to conclude, we just want to say that our goal for this project is to research the different ways in which cloud computing could really change the gaming experience all around. We want to investigate the current limitations and network improvements needed, the pros and cons of the security, and the elimination of personal gaming hardware entirely. Here's the references. Any questions?
I have a question. A couple slides back on the where you put the references, the graphs, It said CDF. What does that mean?
It's cumulative distribution factor.
Okay, yeah.
I had a question about cheating in gaming. I think that's a pretty interesting point. Where do we mostly see that in? I'd imagine we don't see too much cheating on like consoles, do we? It's mostly computers.
Yeah, it's mostly would be PC gaming. Yeah.
Yeah, and with crossplay, I guess it's been a pretty big issue recently.
Mhm,
So,
yeah, because someone could be on their PC cheating and ruin your day.
yeah.
I know Halo had a really bad start to their new game with the cheating thing, especially
Yeah.
cross-platform.
Especially when
Yeah.
when you make the game free, so you can just download it. It really, really opens the door for people to just do whatever they want.
Absolutely. That was a point I didn't really consider with cloud gaming. So
Yeah. So when it's hosted on the server, it's a lot harder to get in there and mess with anything.
for sure. Thanks.
Anyone else?
Seems like a no.
Cool. Well, thanks for listening, everybody.
Yeah, appreciate you guys' time.
All right, that should be all the presentations. So honestly, I don't know what we have to do now. I don't know if we have to go back or we leave. I think we go back to the main room because I see the breakout rooms are starting to empty out. So you guys can just leave the room and I guess go back.
See you guys.
All right. See ya.
Hey guys, seems like your presentation is over. How was it?
It's good, yeah.
It's good.
Yeah, not bad.
Good to hear. Just for Ivan and Thomas, I appreciate to send me the link after the meeting is over so I can put it on web courses. And if you can just upload on YouTube and give me the link, I appreciate that a lot. And once I receive all the presentation from all the groups, I will make an announcement. You can go in and choose the best presentation. Who was the best one out of them all?
Cool.
Yeah, thank you guys. You're good to go.
Okay.
All right, have a good one.
Thank
Sure.
you.
Okay, guys.
I think I have it stored locally. I don't know if I should
Yeah, once
just
you stop
recording.
recording, it will parse it, and after it's parsed, you can upload it on YouTube. And
Okay. Okay.
thank you, Thomas, for your effort. You will receive a bonus.